All right, how we doing, everybody? Doing good. Okay, I just gotta make my introduction. Okay, so welcome to my Thursday labs. Okay, so Monday loves got the love. Okay, but you guys gotta I gotta share the love with you guys too. Okay, so you guys are I guess not the special case. You guys are also a unique case where you guys have more time to marinate with the what do you call it? The content that I've given you. Okay, so you guys can what do you call it? Enjoy the labs, right? You guys, because my Monday labs are being pounded right now with MLK Day, President's Day, Memorial Day, Labor Day, Veterans Day, Monday. Yeah, do you guys like Mondays? I don't know. I think Monday was okay. So, anyways, um, let's go over something I went in the beginning of the class. Let me see. Oh, shoes. Let me do this. You guys want to know how I do my announcements? Let's do it because I see people complaining. Maybe outside. I don't know. Here's my Thursday labs. You guys like my card? Let's see. Announcement. EE320L. PCB design checks. Today in B348. Thursday labs. Thursday labs. Okay. Hello. We moved to B348 by popular demand for KiCAD. David S. Okay, now everyone can come in. Guys like that announcement? All right, who's going to get the buzz? I'll hear no buzz. Everyone put their phone on silent. Great. Or what's that one chime? Oh, that's my voice. Anyways. So, was that video good? Not too bad, right? Let's sign inside a little bit. So, you guys like how I went from the beginning of the, what do you call it? Let me see. Go home. And I'm recording this. Test, just making sure. Let's see. Let's look at this right here. Rev 2. So Rev 2 is, what do you call it? Building on the first KiCAD lab that I designed. And the first KiCAD lab that I designed was for, what's his name? What do you call it? Do you like these figures? Yeah, I put some effort into these, okay? There's a lot of them. And then you can't do it here, but if you download it, okay? Download it. And then let's open this. I don't like Adobe. Let's open it here. Anyways, if you click on a figure right here, how do I do, what do you call it? How do I add a header? Is anyone having trouble with the headers? So I think one of the questions I was asked was, hey, David, I'm downloading one of these parts. Which one was it? It was a two-pin termination block. This guy right here, right? You guys like this block? Maybe I'll bring the pieces in, but I have these pieces. They're pretty cool. They're pretty nice. Let's click on it. I'm going to click on it. Just a moment. Verifying that I'm not a robot. Oh, verify that I'm human. There you go. Okay. And then I click on this, right? And then someone was saying they were having trouble downloading this. But let me click here, okay? The 3D step file, right? Can we see that from the back?
Yeah.
Okay. That's a little too big. 3D step file. And we have KiCAD's V6 and better, right? Or later. Download. I've downloaded this a few times. Let's see if it didn't give me an error. Boom, that worked. I don't know why it always double checks like that. So anyways, let me see. Gives you the step file. This one gives you the mod, the symbol, the step file, how to import them, right? We're getting that, right? Let me see. But someone was generating this error. Let me generate that for you. If I go to, how do I go to incognito mode? Oh, here. How do you know that? I'm playing. I'm playing. Anyways, let me see. Go here. Go here. I'm gonna click, copy this, right? I'm gonna recreate that error, okay? So I'm in incognito mode, okay? Because I'm trying to generate this error, okay? So let me click on models. And then this is what, because someone complained to me about it. Click. I need the, let's keep this unhighlighted, okay? And then let's click on KiCAD V6 and later, right? Okay, you see that right there? Okay, I downloaded it again, okay, right? Right? And then, is this the error that you guys were getting? This right here, the 2 guest downloads? Is that the error? No? Because someone popped out an error which was like, it's making me go somewhere else. And I was like, trying to figure that out too. I'm like, other than use DigiKey, DigiKey is a really popular website where you can purchase any component you want. Capacitors, resistors, ICs, anything you need. Not just components, but like if you need, I don't know, ironing, solder, or what do you call it? I think they sell motors, potentiometer, any piece you would like. Use DigiKey. I highly recommend them, okay? But anyways, yeah, that's interesting. So I was able to save that. Let me see if it lets me do that. Anyone using this device can see downloaded files. That's fine with me. Oh, it gives me an incognito symbol. Not too bad. Anyways, should I start from scratch or should I just talk about the circuit? Because I don't want to go too deep into this because I want to give you guys some time to look with me, okay? Does everyone know how to get to this? Right? Actually, let's not even look at that. Or maybe we should, but was the tutorial not that bad? I walked through it pretty cool. I'm generating an error. And not error, but let me see. Let me get to the part. I'm too lazy. Let's go up here. You see this right here? What's it say? Rev 2 for revision 2. So this is the new content. So one of the things that the engineers were saying is I establish a board, right? And I put stuff on it. But let's just say you make a cake, correct? And you're putting toppings on it, and then you're like, it looks beautiful. I want to make a bigger cake, right? So now the thing that a lot of engineers, I didn't know this was a problem, was that they're afraid of making their board a little bigger because they think they're gonna ruin the cake. Well, you can always make if you have a rectangle cake and another rectangle cake, you can just put them together, right? Put frosting to make it look clean, correct? Correct? So right here, the way that I'm generating, it's not an error, but point is I'm just adding components, right? The op amp, right? And then I generated a funny error because some manufacturers may not follow DigiKey standards. So you got to know that as an engineer. Sometimes the vendor, your customer, your boss is going to give you something. You're going to be like, what the heck? This doesn't work. And that's okay because you're an engineer. You know what's going on. But they don't know. They don't know what you're looking for or what they're giving you, okay? So I'm just telling you this stuff, okay? And then I said, LM741. What else did I go over? Look at this right here. You see this error? Do you guys see this error? Right? The unexpected error that it can't read the file. It's because we had a bad file, so I had to download something different from, instead of Ultra Librarian, I used Snap Magic, right? Not too hard. Any questions about that? Why I'm doing a different file? Anyways, let's see. And then you guys read through it. Honestly, if you literally look at this, it's not too hard or not too bad. You're just putting stuff in. And then did you see how I downloaded another 3D model, right? These are the dual inline dip sockets. Yeah, dual inline. Should be deep dip. Let me see. Is that really what it's called? Dual in place? Anyways, dip sockets. So in the past, I made the students solder the actual op amp, but sometimes people burnt the op amps, right? And I didn't want that, so instead of burning the op amps, we're gonna solder a dip and that's actually, it's only 20 cents. This thing right here, it's pretty cheap. You want to see it? This is the hyperlink people were telling me. So if I click on this, right? So let me see. How much did it cost? 16 cents, right? But if I buy, I think I bought 1,000. So it only costed 9 cents each. So I'm happy to burn this. Okay, because someone's saying, dude, I'm gonna steal all these op amps. Boo ha ha. So let me see. Let me show you, because some of you guys, I need to tell you guys, I need to be more transparent about. Please be mindful of the resources we have. So I'm gonna click on this link. Okay. How much does the op amp cost? Yeah, it's expensive. It's $1. It's $1 each. Those little tiny guys, and you bent the pins, you break them, you're like flicking in the trash or don't clean up after yourself. These are actual components. If I buy 1,000 of them, it's 50 cents, right? But I'm still paying up to $500 for just 1,000 of these op amps, and I burn through maybe 100 of them every when I have that experiment. Okay, what's his name? So if I have people soldering them and taking them or burning them, it starts becoming overhead that I can't oversee. Anyways, let me show you this other op amp, because this is another thing. We're building an op amp, universal op amp tester. Did you understand how I was doing the layouts, right? So you're going to punch in the chip. Funny enough, I tested this other one. It's called the UA741 op amp DigiKey. Let's see if we can find it on DigiKey. There it is. UA741. You guys know this puppy? Let's see. Where is it? Where is the dip? Right here? Obsolete? Well, I guess they don't sell it anymore because it sucks. But they do have these smaller chips. I see right here, it's 50 cents. Not too bad, but why can't I find... Anyways. But yeah, these are a little cheaper. And then there's another op amp I want to tell you guys that you can use. It's called the TL071. Okay? So I haven't told the other class, so you guys are a little more special to know this. Okay? And we're looking for the, what do you call it? The dips. 8 dip, right? If I click on this right here, how much does this cost? 50 cents, right? 46 cents, right? But if I buy 1,000 of them, it's only 20 cents, okay? You start seeing how you have the same components, right? Kind of. They're both op amps, right? But you have to start looking at the data sheets for what do they do, your projects. So when you take this to senior design and you're like, should I buy? Because if you make a company, right? 1,000 PCBs, correct? And I'm going to have 1,000 op amps to buy, right? So $1 is not too much, right? But 1,000 PCBs, $1,000, it starts becoming expensive. And then you start getting into the philosophy of when people cheap out on electronics and they're trying to print out 1 million copies, right? Or 1 million devices, 1 million USBs, or I don't know, cameras, right? Stuff like this right here. Or here's another camera. You're building 1,000 of these pieces or whatever. Anything that saves 10 cents can save $1 million in the long run. Okay? Does that make sense? Anyways. So everyone understood what I was trying to do here. This is going to be on your post lab, right? Everyone's going to take this picture. Better yet, how are you going to make this prettier? Let's see. Let me move this. I don't like this right here. I'm going to move this right here. I don't like doing that. Boom. I'm messing things up right here. Let me see. Resistor. Control C, Control Z, Control Z. You know what I'm going to do? You can do this. Control, click, Control, click, Control, click, Control, click, Control, click, Control. Don't forget the power flag. This right there. This right there. This right there. Come on. There you go. See if I can move all this. There you go. Does that look better? Right? A lot more spaced out, right? So how do I make this more prettier? Okay, so you guys are going to get this special treatment, okay? I haven't shown the other class. How do I make this prettier? Let's place. Let's draw rectangles. Like this, right? Right? And then I right click on it, look at the properties, right? Do I want, let me make a really thick guy, 10, right? Let me do a solid dashed. Ooh, you guys are getting, ooh, look at that. See? You guys are getting this material, okay? You guys are getting pretty graphs, okay? So let me see. Pick a color. Should I pick red or blue? Yeah, let's pick red. There you go. Boom, boom, boom. Is this gonna work? You guys like that? Cool. And then I'm gonna go to view or place text. And then this is gonna be my voltage divider. And then put a smiley face or whatever, okay? Click. Cool? Or better yet, can I press Q? No, it won't let me. Oh, I didn't know you can do that. Q for no connect? Cool. How do I get to properties? Is there a shortcut? E. So if I click on this and press E. Ah, I like that. Okay. So let me make it thick like that. Let's make it 100 text size. You guys like that? So then when you have your senior design presentations, right, you're going to be like, this is my block diagram. It looks really nice, really pretty, right? And then these right here, well, what should I put inside my voltage divider? This is my ground, right? Make sense? This right here is for my voltage divider too, right? Is that cool? What am I going to do here? View or place, rectangle, boom, or boom, boom. Oh, what the heck? Come on. Draw rectangle. Boom. Okay. And then E to edit. What did I use? 10. And then I used, let's use dash dot dot. Okay, color. Let's make it blue. Does that bother anybody? All cool, right? And then you're gonna do this. Let's put this text. Place text. My universal op amp tester. Okay. Is that cool? So is everyone understanding what I'm doing with the schematic? Because I talked to my Monday labs about this. We have an op amp, right? What does an op amp need? Negative feedback. So here's my output feeding back to my negative terminal, right? To introduce that negative feedback, correct? What do I have right here? Not cadence. There you go. I'm using Q. This is my header, right? You guys know what it looks like? Let me see. I'll probably get to the answers later. But anyways, these are just pins, right? They're just static pins, but I just short them together. I shorted this side and this side, okay? So this side's going to be on the negative, right? Correct? Is that understood? And then this side right here is connected to the output. Do you know why? So that I can put a resistor here, right? From here to here, right? Or I'm going to do it for you guys too. If I add a component, A for component, don't do this, okay? I'm just showing you as an example. Res, R, American, because that's what I know. Okay, see this? Copy, boom, boom, boom. Boom, 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 boom. Okay, so we would solder the resistor and the capacitor on the board, but I want you guys to have fun, okay? You guys are going to show me, like, remember the integrator example, right? And remember the differentiator and the non-inverting and the inverting one, right? Remember those? So now you can just plug and chug, right? You guys seen that? How about here? I'm going to press C, Control C, Control V, click. I'm going to do W for wire, click, click, minus, click, click, minus, right? What's this resistor right here? This is my feed forward resistor, right? Right? This is going to be like, I don't know, 1K, right? And this right here is my feed back resistor, right? 10K, right? What's the gain? For, what do you call it? An inverting op amp, with this being 10K and this being 1K. Minus 10? Right? Because we have negative feet. Well, it's an inverting op amp topology. Okay, so someone's probably asking the question, David, what about the positive terminal? You don't know what I'm going to do with this terminal when I get the board back, right? I'm going to grab one of the jumper wires, right? The jumper wires in the labs. I'm going to wire this like this. So W, 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 there. That's my wire. And then where is this plus going to go to? Ground, right? Because that's the positive terminal is grounded, right? I'm getting blank stares. I don't like that. Let me see. KiCAD, spring. There's a lab 2. Let me see. Should I use a simulation? Yeah, sure. No. Right? Not too hard, right? So you see the plus right here is grounded, right? Just like this guy right here, grounded. I'm gonna put. Don't do this. Yeah, it's okay. Anyways, you're gonna put a ground. You're gonna force this one to ground when you build it, right? And then this right here is my feed forward. And then look at these two components right here, right? Right? Feed back. And then what about my output? So you see how I have, this right here can be act as my output, right? So I was gonna do it where you guys have to make like a, what do you call it? A pin for V in and V out, but I don't want to burn money. These components right here, these headers are 50 cents, and 50 cents times 30 students, it's not too much, but over a while it becomes a lot, okay? So that's why I'm not trying to waste too much money, okay? Unless you really want to impress me, but be my guest, okay? You know what? Maybe that might be the bonus question. Make your minus, like V in, here's your V in or whatever this is. Yeah, this one, and this one, give it its own terminal, but I'll have to very design check it, okay? So only do that if you really want to impress me, okay? So anyways, what's the command? Control Z, Control Z, Control Z, Control Z, Control Z, doom. Right? Is that good with everybody? What's the next step we're going to do? ERC? Run the ERC? The current configuration does not include the footprint. Great. Who's getting this error? So usually this error comes from, like, you're not, like, coming back to the, what do you call it? Let me see. You know what I'm thinking? Let me see something funny. I think this is another student's project. Yeah, this is another student's project. Because you know what I'm doing? Everyone's gonna have a screen here, so I'm gonna look at it. But some people are sending me their like actual design file because they do it from home or from a laptop. But for some reason the laptop doesn't work, so they send it to me. So I open the folder. Let me see. So you know what? This is a student's board. So it's not my board. So they're having this error. Let me do an ERC. So some of you guys are going to come to me and complain to this. So you know what? Thursday's live video is fix the errors that people are having. Is that good? So give me some questions. I'm getting this. It says, this does not have a footprint. How do I fix that problem? Let's look, double click into this. Oopsie daisy. We got to assign a footprint, right? Let's see where the student put all his stuff. So we got to declare something to this, okay? By the way, if you're doing work in this lab, when you make sure to what do you call it? Let me see. Let me just wait for this to load. Okay. Yeah, because they're getting errors there too. Let me see. Make sure when you're doing your PCB design, put it in a directory like this. Call it KiCAD PCBs. Call it KiCAD or my KiCAD work or my PCB design work, okay? Right? Click into this folder. You're going to have all your PCBs, right? Here's my my Monday special because I did the PCB with them. Here's another senior design board that someone showed me. Here's my first PCB, right? Here's my downloaded parts, right? So that when I go back here and zip this all up right here, compress to zip file, let it do its thing. I can email myself, okay? And then email myself because these computers will wipe, okay? So I already had one student say, I didn't know it wipes. I'm like, have you been doing, I don't know. Anyways, so make sure to back up your work in one big folder, okay? Some people are doing it on a desktop thing and then creating a folder there. That's okay. Don't make sure it's organized so it's easy to zip, easy to take home, easy to get out of here, okay? So then when you're giving me your email, I need to see the downloaded parts because that's the parts you're instantiating, correct? And whatever your PCB is, my first PCB, okay? So let's see if the student did it correctly. They're going to get the special treatment today. What was it called? Where is their PCB located? Let me see. Where am I right now? Double click. Footprint. Something else is going on here. Let me check their main KiCAD menu, okay? Preferences, manage symbol libraries. Let me see where they saved it. Interesting. Because I know there's a way to just store it easily, but where is my file? Let me just see where this is. Save as. Where am I saving this to? lab5_1. Okay. So I'm gonna go here. So the student sent it to me like this, and he put it to me as lab5_1. My PCB. So this is the student's work. Where is his? It's right here. By the way, delete these zip files. You don't need them anymore. Okay? They're just collecting a lot of clutter. See, my first PCB. This is lab 5. Oh, they really gave me everything, huh? Anyways, delete this. Delete this. Delete this, okay? So what is this? Because I don't know what it is either. See, this is why I don't like not naming things. This one looks like my header, right? The green header. I'm going to call it green 2-term header, right? Is that correct? And then this one, I don't know what this one was. So we're going to have to investigate pretty deep. So anyways, can it let me do this? Let me just try something, okay? I'm going to click on this symbol, or let's do the mod. Okay, let's see what happens. Does not appear to be a project file. Let me see. Mod? It's not letting me open it. To open footprint, let's go footprint editor, okay? Errors were encountered. It doesn't like that file either. Okay it. Come on. Let me click on this. Mod. What's that one? That's my green header, right? Right? So I don't like these names, okay? So I just determined that this was my green 2-term header. So I renamed it from that 612, the random numbers, right? And I just renamed it to green 2-term header, right? So let me go up here. Let me go back to the footprint editor, right? Here's my footprint editor, right? I'm going to click and drag this mod right here. Let's see what it is. What's that? That's my 2x4 female header, right? So I'm going to do this. You can do this with me too. I'm going to generate these errors, right? 2x4 female header. Okay? So it makes it a little easier, okay? I'm getting rid of all those funny numbers. And then I don't think the student downloaded the file I want, but we'll do it. We'll do it together, okay? So we're going through all the errors together. No. Let's go to your schematic. So let's go to, oh, this is very important. If you rename something in your folder, it won't change it in your path. Am I clear with that? If you change something right here, KiCAD doesn't know that you did that. So let's go back to our main menu. Go to Preferences, Symbol Libraries, okay? Let's go down here. I'm going to create a new one. Plus, I'm going to call this one my green header, right? And then down, it's going to be here. Let's see, it's in my downloads. Or no, whatever it is. Downloads, Lab 5, this guy right here. Green 2-term header. What am I looking for? The symbol, right? Link it. Okay, symbols linked. Understood? Okay it. Okay? So then, let me see. Let it do its thing. Okay? Do you have headphones, by the way? Thank you. Now let's go to Footprint Library. And then let's do the same thing right here. Let's do my green, what did I call it again? Green headers or something like that. Is that correct? I'm going to click on this folder right here. Boom. Boom. Okay. Green 2-term header. But where was that folder? Before I do that, where was my footprint? The green 2-term header, right? And it's right here. It's just there, okay? So you're going to select that folder, right? So let's see. Green header. Or let me just recall it like this. Green. Come on. Green 2-term header. Okay. Select. I'm just trying to generate these errors so that you guys can fix this on your end too, okay? Not this one right here. Green 2-term header. You're not going to see anything here, okay? But you need to know that there was something in there, all right? We're looking for a folder. Select the folder. Okay, let it do its thing. Boom. We've linked the symbol, right? We've linked the footprint, right? But now we got to do something magical with the actual symbols. So let's go to Symbol Editor. Let's find that green header. Right? There it is. Correct? What's the next thing we're going to do? We're going to link this together with the symbol properties, right? What's the footprint? We got to link the footprint, right? So let's link the footprint. Let's type in green header. 2. What did I call it? What? Let me see. Give me a second. Give me a second. Preferences. Footprint library. What did I call it? Green 2-term header. Let's go back here. Okay, you gotta. Sometimes you gotta keep these names consistent. Boom. Okay. Symbol properties. Here, I call it green 2-term. What? What? No. That's not right. Footprint chooser. Let me see. Because someone's gonna also complain to me about this too. They'll be like, you see, you can't find it either. Green 2-term header. Green 2-term header. Don't tell me this one's damaged. Green 2-term header. Okay. Where is this? Save. Yeah, sure. Oh, I re-download or KiCAD. Come on. KiCAD. There you go. Let's look at the schematic because I don't want to do it the hard way. So anyways, you see these guys right here? Maybe we'll do this. Double click into that. Let's add the footprint. Let me see if it's here. I don't know. Let's check. Okay, that's fine. Green. There it is. I don't know why it wasn't happening. Okay. So do you see that the name changed? Green two-term header, and it's calling that funny name. It's like number. It's like 691137710002, right? So this right here is that parent folder, and then this is whatever the component is. All right, sounds cool. So I'm a little lazy. I'm gonna do the following. I'm gonna delete this. I'm gonna Control C, Control V, so I don't have to do that anymore. Okay, right? And then same thing right here. Delete, Control Paste, rotate, rotate. Boom. Is that good? Let's ERC it. I had 10 errors. Now I'm 7. Okay? So we're getting close. So now we got to deal with symbol. What are you talking about? The current configuration does not include the symbol library. Does not copy this. Someone's going to find these errors. So this student had funny errors, and I guess they were having warnings. See. You know what? I'm going to do something even wild. I'm going to delete that whole thing, reinitiate it from scratch. No, because I need to first fix this guy. Give me a second, everybody. Green, two-turn header. Green header. My green header. Right? Symbol properties, okay? See that right there? We need to get rid of this. This needs to be that one footprint. Green, 2. There it is. You see, okay. So I think what was happening was I put the file, the library path, right? You guys saw me, right? I'm not crazy, right? But the way for it to refresh is you have to exit out and then open it again. Okay? No one's going to complain to me about that error, correct? Okay, I'm here to show you guys the errors so that you don't get these errors, okay? Anyways, double click. Now this makes life easier, okay? Now we never have to worry about this problem again, okay? Save it. Don't forget to save it. It's called My Green Header, but I called it the Green Two-Term Header, okay? I have different names for symbols and footprints. Cool? So I'm going to exit out of there. I'm going to go to the footprint editor, okay? This is what you're going to be doing for your 3D model. So let's go to Green Two-Term, right? Double click on that, right? I'm going to go to File, Footprint Properties. Go to 3D Model. This is where you're going to add your models, okay? So this guy, well, let's delete that. There you go. Let's find the step file. Where was it? Downloads. This guy's lab. The green headers, right? And we're looking for the step file. Okay it? Does that look cute? All right? Okay it? Save it. Exit out of there. Now that I did all that, let's just delete all these guys because I don't want to generate that error again. I really don't. Delete. You guys like it when the lab director makes errors and then fixes it right in front of you because you probably have a question that you're not asking me? Wow, he's reading my mind. Green header. My green header. Double click. Or there we go. Punch it in. Control C, Control V. Boom. And then right here is Control V again. RR. All right, now those errors should go away, right? All right, I'm not crazy, right? Run it. 4 errors. Let's go. Woo! So now we got to fix all these other big parts, okay? So what are we gonna do? So let's go. I know this is a long process, but I promise if you do this right now, life will become a lot easier. So let's go check this guy's headers. The 2x4 female header has the symbol, the step, the mod, right? Symbol, step, mod, right? So let's go find it. Symbol, I'm going to rename this again, okay? I'm going to call this one 2x4 FH. I don't know, female header, okay? I'm just making new content for you guys, okay? So so Monday Labs, they got the full run. You guys probably have the same questions that no one's asking me, so I'm here to make sure you guys, all these errors are gone, okay? Because I'm also trying to figure out this too, okay? So 2x4 female header, right? Find the library. Go here. Where's my 2x4? Click there, symbol. Boom, done. Let it do its thing. Convolution? Who's taking that 320 exam or 360 exam? Who wants to do a review with me later? You guys are getting your money's worth, huh? And then anyways, let me just do one more thing so that nothing crashes on me. Let's see if this doesn't crash. So yeah, not too bad. Actually, I have a better diagnostic question. Who's already finished the PCB lab? 1, 2, 3. Okay, so then right after I finish this video, you guys are going to be the first people to check off, and then you guys are done, and then you can purchase the boards with me next week. Anyways, forgot to charge my laptop, you see? Lab director's got too many things going on in his head. See if this doesn't ruin the video. Okay, we're good. I just did the symbol, right? Let's do the footprint. Footprint properties. I'm going to call this one. I'm going to rename it. I'm going to do a 2x4 header. Should I just call it head? Yeah, whatever. Just to keep it like, you guys seeing how I'm doing different names? Don't be afraid of using different, whatever makes it easier for you, okay? Don't use the default, like the weird, I don't know. Go ahead, even deeper in the levels. Call it whatever makes sense to you, okay? KiCAD is super open source. You can do a lot of cool things, okay? So, boom, boom, boom. 2x4 female header. Click there. And okay. Let it do its thing. Okay. And then I don't know why it's gonna do it. Let's just get rid of. Let's close out of that. Let's close out of that. Let's close out of that. Let's restart. I don't know. I have trust issues. Okay. I don't want this to fail. Let's go to footprint editor. Or no, not the footprint editor. We're gonna need that later. I'll fix that error later. Not that one. Symbol editor. Okay. Let's go find that symbol. Okay. What was it called? 2x4FH, right? Right? Double click on that. That's our header, right? File, symbol properties. Let's see. Let's get rid of this. What was the other thing? 2x4 head, right? Calling it head. Okay, see how it changed the name? Right? And then if you really want to, be my very guest and do something deeper with this. But personally, don't, because it ruins everything from the top level. So you have to reinstantiate everything, okay? Okay it. Save. Boom. Set. We're done. Go to our footprint editor. I already have that open over here. 2x4 head. Double click. Okay. Go to File, go to Footprint Properties, 3D Models. Let's go find that model, right? 2x4 female header. It's called a step file, right? Click on it, open, boom. You're done. Okay it, save it. You're ready to go. So then what am I going to do next on my schematic? Okay, I'm editing a student's board, okay? I'm going to delete these because I don't want them anymore. I could reinstantiate them or rechange the names, but I don't have time for that. So let's do A for instantiating pieces. What's it called? 2x4FH, right? That's what I called it. Put that right here. R to rotate. Control Z. Control C, Control V. R to rotate. Boom. And then Control C, Control V. Boom. Is everyone understanding what's going on there? Check and save. Let's see. One error. The op amp, right? You see? You guys like that I'm generating errors for you? And I'm fixing them for you, right? I like the head nods. One more thing, okay? So let's find the op amp, okay? I don't know. This student sent me his funny board. He's doing a great job, okay? He's doing great. But I want to make sure you guys have a little more perfect schematics that you can understand for your senior designs, okay? I'm gonna go to let's see if he even downloaded it, okay? He downloaded it here. He got the step file. He got the symbol. I don't think this is gonna work. So okay, I have that piece right there, right? The op amp, right? I'm gonna go to my document here, right? Let me download this piece right here because I don't talk about this. I talk about it in the lab, but I don't show how to do it a little bit deeply. So yeah, this is new content a little bit. Okay, where is it? So I'm gonna go here, right? Digikey.com. Click on this. Actually, no, I lost it. See, this is why I don't like clicking on things like that. Newly added PCB. What is it called? Here it is. Female header? No, not female header. Where's the op amp? Where's the op amp? Sorry. Here it is. Middle click. There we go. I'm going to download it right in front of you, okay? So everyone's watching that I'm downloading, okay? I like this footprint, right? This one's not the right model. I don't like it. I don't need that, so I'm gonna steal this footprint, okay? I just need the footprint. Is that understood with everybody? I need the footprint and the not the step. Well, I do need the step too, but okay, because I want okay, I'm gonna download this, okay? Download. I just need the footprint for this guy. So what am I gonna call this? Just let it do its thing. So I'm gonna grab this. I'm gonna Control X. Let's go to this student's lab. Yeah, this student doesn't even know we're doing this. Anyways, right here. Here's his parts right here. I'm going to paste it right here. And I'm going to call this the what do you call it? The 8 dip footprint. Right? Because I just need the footprint, right? Is that correct? Okay, and then I'm going to extract this. Extract all. Extract, boom, done. Okay, and footprint. I want this. I want that KiCAD.mod, right? So let's get rid of this guy. So I don't need this. Okay, keep the folder. Now let's download this guy because this is the milk and honey right here, right? Big cheese. Or what do the Zoomers of today say? Gen Alpha? I don't know. They don't say let's get this bread anymore, right? No. Dang, yeah, they got some new lingo. Anyways, let's call this one the 8 dip 3D model, right? Right? Okay, everyone understanding what I'm trying to do, right? Let me go to this guy's lab. Okay, this is some student's lab. He's probably gonna be like, what the heck is he doing? Okay, I like doing these. I like videos. Okay, extract all, okay, boom. So there it is, okay. So let's go out of here, delete this, okay. So we have a unique 3D footprint, right? Or footprint, a model, right? And I have a I have a 3D model, the step file, right? I have the actual, what do you call it? The footprint, right? The footprint that I'm going to be soldering onto my board, right? And then I have the LM741 op amp. We have 3 unique pieces. We need to put them all together. Is everyone understanding what I'm trying to do? Right? So we're basically Frankensteining this, okay? So let me go back here. My first PCB. Let's go find it. Manage symbols. Let's see. Did he do an op amp? Well, I did one. Let's do another one. I don't know. I'm going to call it 741 L, or I don't know, 741 op amp. Okay, I'm trying to do different name conventions. Okay, so you guys are aware of what I'm trying to do. Okay, so I'm gonna find that op amp that the student bought or got. Okay, right here, right here, symbol. Boom, I'm done. Okay? We declared the symbol, right? Now we got to hunt that footprint. Okay? Let it do its thing. Convolution. I like convolution. So I'm going to go back down here. I'm going to call this one 741 op amp. Okay? Let's go find that op amp. But it's not an op amp. We're using the dip, correct? Right? Yes? So let's go find that footprint, the 8-dip footprint, because the op amp is going to go inside the dip. Right? Yes? Or no? Good. Okay, that's what I was expecting. Okay? Footprint. KiCAD 6. Footprint's pretty. Boom. We want that. Okay? I want the dip. Okay? Okay. And now let's go back to our symbol editor, okay? Because we need to tie the symbol to the footprint. So let's go. It's called 741 op amp. Okay, that's your op amp, correct? File, symbol properties. Ooh, let's change that. Okay, whatever. What was my footprint called? 741 op amp. But that's the dip, right? Are you guys seeing what's going on? Boom, done. Okay? So now, save. Let's go to our footprint itself, footprint editor. I know this is very tedious just for a simple board. Let's go to 741 op. Okay, double click. File, footprint properties, 3D model. What are we going to do? Plus this. Let's go find that 3D model, right? Double click, step, boom. Does that look good? What was the magic numbers? I forget. This. No, that's upside down. This. Raise it up. Am I getting there? No, it's flipped. There you go. I found it. How am I going to do this? Let's do this. Go down to go up. Go right to go left. You see that? What's going on? Put it down with the Z-axis. Guys like that? Looks cool? Is that... You see that crevice right there? Right? It's pointing up. Makes sense? And then, what's the next thing I want to add to this? The op amp itself, right? So let me go plus right here. Right here. Let's go find that op amp. 741. The step file, right? Click on that. Boom. All right, let's lift it off. You guys like these little caterpillars or centipedes? What are we calling them again? Delicious. And then let's move this down. Let's look from the sky. Is that kind of in the center? Yeah? And punch it in. Guys like that? Snug and tug. Cool? Whew. That was a lot of setup for just that. I'm not saying you're going to do it. So once you get it set up the one time, you can build so many circuits, right? If you have an Atmega 328p, you guys know that little chip, right? Yeah, you have to do the symbol, the footprint, and everything. Now you can build a microcontroller. There's this one senior design team. They designed with like the ESP32 chip, like the really tiny one. They're doing AI glasses. They made this really tiny board, and they did exactly everything I said. They got the actual symbol, the footprint, and the 3D model. Bro, it looks legit. It's really, really cool. So after this class, you guys can go build some AI glasses, okay? Anyways, that's a lot of setup. Once you guys get it done, you're pretty much good. Let's go back to our schematic, okay? What am I going to do to this op amp? Delete it. Let's go find it. What was it called? 741? Op. Double click. And then let me show you one more important thing. If I press A again, do you notice that the symbol and the footprint are right there? That's to tell you you did it right. Okay? Okay. What happens when I check and save it? Or ERC it? Let's go W all. Let's go. This is a screenshot I'm expecting for your pre-lab. This right here tells you, congratulations, you got your ERC, electrical rules check done. This is screenshot 1 right here. All right. Ignore tests. What did we ignore? Don't worry, because we're not doing spice, okay? There's a way to get spice to work on this, but that's a headache, okay? And then this is your next screenshot, okay? Screenshot this guy right here and screenshot this guy. Put your name on it, okay? So I make sure it's all unique, okay? Maybe you can do something cool with this, okay? Leave that for your homework, okay? Does that make sense? Save. Let's go to the layout. Let's go see the student. Let's get rid of his name. You can check that out later. Save. Now let me do something funny. I'm going to update PCB from schematic and see what this does. I hope it works what I think it does. What the? That's funny. Okay, let me see. Whoa. I want to see if it lets. I don't think it's going to let me do it. Control Z. Okay. So when you do a master edit on the schematic, you change the symbol, you change something in the footprint, you change something in the 3D model, there's a super high chance you need to reinstantiate that footprint. So you have to do the following. Nuke it and just replace it. It's right there. Okay? Does that make sense? So one of these are not like the others. Let's see. Let me, which one was it? Was it this guy? I don't know which one it was. How do I tell which one is which piece is which? So if I select this piece, right? Which one's lighting up golden on this piece? Let me just do this. This is a good demonstration. What circuit is this right here? My voltage divider, right? What's connected to my voltage divider? V in and V out, right? I'm going to select this right here. This header right here. Let's see it shine. You see it shining? It's glowing, right? Right? You see it glowing differently? So if I click on this, or what if I click on this? Do you see how this can help you? So I'm trying to say, KiCAD is super great. We used to use like Eagle, and Eagle was cool, but it crashed and they got like canceled, cultured. I don't know, one or the other. It wasn't software. It was AutoCAD or something. Then there's OrCAD. Has anyone heard of OrCAD? That's a cadence application. It's painful. Who here has heard of Altium? Yeah, Altium is one of those, what do you call it, industry tools. Yeah, it's expensive. I really want to work on that. That might be a special lab. I'll think about it. But I'm introducing everyone to KiCAD because everyone has the opportunity to do it anytime, anywhere, at home. Make your own company, okay? So basically, I don't want to. The reason why someone was saying, why don't you teach Altium, is because if I only teach you Altium, then you won't know how to use KiCAD, and then most likely you won't touch it ever again. And that's what makes me really sad, is that I teach you everything, and then you can't use it because you're not exposed to it. Does that make sense? So I care for you guys. I want you guys to take this home, go make a company, because I know people who've made like thousands. I had this guy. He's already make like I think like $100 from selling it on Amazon. It's just a simple Christmas tree. Okay. Back to my lesson. So if you're re-updating these parts, let's do this. Which one was my glowing part? This guy right here? Let's see. Let's delete this. It was this guy. Let's see. There we go. J1. Okay, man, I'm doing some advanced editing, so this is what I'm basically fixing someone's circuit right now. You see the V in and the V out pin right there? Punch that right in the middle. Is that good? Cool? What am I going to do with this piece right here? This is connected to G and D, right? What's this right here? Eyes? I don't know. It looks like eyes. I'm going to just try to see if I can mark that right there. Boom. Is that good? Right? See, I'm fixing your circuit. Okay? What about this guy right here? Goes down here, right? And then look, I have VDD minus and VDD plus, right? This is VDD plus, VDD minus. Make sure the rat's nests are okay, okay? Wait. Gotta delete this part. Wait, let me just check something. Okay. Control Z, okay. Make sure I'm not going crazy. Is that cool with everybody? Let's do the op amp. So I'm going to delete this op amp footprint right here, right? It's gone now, right? I'm going to replace it with this guy. And let's see if there's any difference, because I actually think I'm actually a little afraid. Ooh. Ah, yeah, you got me there, buddy. Okay, we're going to have to do an emergency surgery, okay? Delete this. Okay. So let's delete all this, okay? We're going to perform some surgery, okay? Who here wants to go to med school? I think you can go to med school after this too, right? Okay. So I'm going to put this piece, okay? This is our new footprint, okay? Look at this. Look at how legit this thing is. Okay? I'm going to press B to fill. Okay? Now it moves everything around like squishy parts, right? All right, and let's just leave that there, okay? I have other things to finish. What about this guy right here? This one goes to my minus and negative. Minus and negative. Delete that one and replace that with this. R to rotate. Is that in line? Yep, it looks like it's good. Let me press B to fill. I don't think it is. And whatever. Actually, I think it does. I think it does bother me. If you want to move it a little more microscopically, you can use the grid tool. And then I can move this a little more. Let me see, a little more fit. Is that better? You guys seeing how I'm changing this? Is that cool? I don't know if I like this. I think it should be fine. I think this is fine. B. Yeah. Do you guys like that? Pretty cool, right? Let me delete this right here. Positive plus. Okay. And then let me get rid of this. Who thinks I'm here wasting your time? If you think I am, well, it's okay. Or I don't know. Just let me know. Okay, because I wish I was in a meeting right now. Right now, they're doing an interview for the new analog professor at 1:15 or 11:15. So I was like, I wish I can go to it. It's okay. Anyways. Yep, we're getting a new analog professor. Guess what he's going to be teaching? 420. Yep. Our new 420 professor. Is that looking cool? You guys like that? Cool. And then let's do one more final step. Here's my minus. Here's my... What is this? Output negative. Okay. Get rid of this. Delete. Boom. Or let me just rotate. Rotate. Put this right there. Guys like that? Press B to fill. Cool? Any questions about that? Oh yeah. Op amp, right? We gotta do the surgery, right? You see that negative right there in this terminal right there? What are we gonna do? Grab my blue pencil, right? And then if you guys did my tutorial, right? What's the track property? Or go to track or right click on this. Go to properties. How big is that track? 40 milli or 40 mils, right? So let's go grab my 40 mil pencil. X. Boom. Done. Right? What about this one? Well, I need my red pencil, right? X. Boom. Done. I don't like that kink. There we go. I like that better. It's a little more filled. Okay. What about this VDD? X. Kink. Boom. What about this VDD plus? Here's VDD minus, here's VDD plus. X. Right? I'm going to press plus right here. Come on, right there. Boom. And then how do I make it look a little prettier? Press B to fill. It's looking more legit, right? Cool. Is there any other pins? Oh yeah. You see this output right here? Let's go underground. Okay, I'm gonna do the blue pencil, right? Blue pencil, correct? Go here. Boom. 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 Did we fix this student circuit? Right? I don't know. Let's just DRC it. Well, save it, right? Let's DRC it. Or not, design rule check. Where is it? Right here. Design rules check. No errors, right? But we have warnings. What are the warnings that I don't like? You see this text right here? Right? Delete it. I don't like it. Okay. What about this one? Delete it. Don't like it. What about this guy right here? You see that right there? The number 69? Delete that. What about this number right here? 61? Delete it. What about this J6? What does J6 stand for? Jumper 6? Not the other J6? I'm blank. No. Anyways. What about J4? Let's delete it. It's okay. J3. We can keep it. Whatever. What about this asterisk? Convolution?
Yeah, convolution.
Let's keep it there. Okay. Yeah, it complained. It's like, look, convolution. What about this guy right here? This text, LM741. Maybe I can put it right here, but I'm gonna. Doesn't matter. No, it doesn't matter. Let's just keep it there, okay? Let's delete this guy right here. And I think we're good. Let's check and save again. DRC. 6 errors. Footprint G. Where's footprint G? Oh. You see this J5 right here? Move it down. Run it again. See, look, now we have 5. Where is G? Wait, the current configuration does not include... Are you kidding me? Doesn't even like the logo. It says, hey, we hate the UNLV logo. Sure, mister. Footprint properties. What am I going to do here? How do I make the UNLV logo look nice? I'm going to call it my UNLV. I'm just going to call it UNLV. Here, footprint. Where's my UNLV logo that the student did? Ooh, I don't know if he did it. Ooh. Let me just check. Let's see. Okay, he did. Perfect. KiCAD. Boom. There it is. So what are we gonna do with the UNLV logo? Delete it. Reinstantiate it, right? Press A to reinstantiate or to add. Exit out. UNLV. Okay. Reinstantiate. It sounds so weird, but yeah, you have to reinstantiate things. Save. Let's run the DRC again. 4 errors. Text height out of range. I set a rule to 30, but it's actually 25 mils, right? Remember the tutorial? Where I was like, let me see. What do you call it? Was it called design rule check option? what do you call it? No, it was called Osh Park. Remember this right here? Minimum text height is user preference, right? How do I get rid of these errors? Right? It's user preference, right? So let's go here. So basically, this is basically like for you, like, oh, because I'm looking at the board, can my eyes enjoy it? I'm just trying to get home, okay? Go to constraints. You see that 30 right there? Let's set it to, I don't know, 20. Or you can set it to 0, be my guest. What are we going to get? DRC. What's aura farming or whatever. That's a screenshot. You know what this means right here? We're ready to fabricate this. All right? So I want to see this screenshot right here, and I want to see this other screenshot right there, okay? Is everyone understanding what I'm going to be checking for your design rule check? So TLDR, make sure you don't have any ugly kinks. Like if I see something, let me see the student. This might be an antenna. I don't know. You know what? I'm going to fix it. Whatever. I don't like that either. I don't like this. There we go. I drew that. See? Now it looks a little more cleaner. Oh, this is an antenna. That's an antenna. Whatever. I don't want to see right angles too hard. This is fine. This is fine. You see, I want to see these nice 135 degree angles, like nice curves. See, everything's kind of curvy because an electron, think of it like a ball. It's going through a pipe. If you have a 90 degree angle, if you take Dr. Harris's high-speed PCB design class, it's a 700 level course. You'll notice that if you have a corner, if you shine a light at the corner, yeah, it goes through the wall, but a lot of it bounces back. So for high-speed PCB design, but we're not doing high-speed. We're doing like 1 kilohertz. So else, this student's board, if I look at it, he has the ground vias, right? Do you guys know how to do the ground plane, right? You guys are understanding why I'm doing a ground plane? Because they're gonna give you a piece of copper, top copper, bottom copper. It's gonna be an empty piece of copper, right? And they're gonna etch it with like a little knife, right? The reason why we put this copper here is so they only etch out. Let me show you. 3D viewer. Oh, let's go. Okay, you see this right here? That's the etch. They're gonna etch this out. Okay, does that make sense? And this is right. This is copper. This is copper. This is copper. This is an etch. Okay, does that make sense? And this will take 2 to 3 business days to build. So you know how some PCB manufacturers say 3 to 7 business days? If you do the following, let me delete this. View, 3D viewer. That's our copper right here, right? But you see there's no copper there, right? Right? Are you seeing that? They're going to have to etch out all that copper. You're going to be the 7 business day guy, okay? They're going to look at you and be like, okay, 7 business days. Okay, so that's why we have to put the ground plane, so it makes it faster for fabrication, okay? And then here's our ground via. So let me see. Does everyone know how to do the ground via? Or the ground plane? You want me to show it to you? Not Control Z? Yeah? You're going to press this button. Okay? Everyone has to press this button. It's right here. Draw filled zone. Okay? And then let's click on the corner. Like right here. You're going to select FCU and BCU for front and back copper on GND. And then okay it. Now let's draw a square. Or a rectangle. Right here. There we go. Guys like this art class? Very artsy. And let's just, it's not going to be perfect. Oh, actually, I don't like that. Let's do it again. I don't know why I can't, like, just, you know what I'm going to do a crazy design, whatever. Because it won't let me hold Control or Alt or anything. So, boom, boom. I'm going to make it ugly. You guys like that? Double click. You guys like that ugly shape? I'm just showing it as an example, okay? Because some people are going to be very picky, OCPD, and be like, okay, let's get to work. Press B. Still worked. Any questions? Does the thing work again? Control S. View. 3D viewer. Right? My first board. You're gonna put your name, your team partner. Don't ditch your partner, okay? It's one PCB per team, okay? So make sure both of you get the same experience, all right? And then, okay, I'm gonna do it for this class, whatever, okay? You guys are gonna get your money's worth. Fabrication outputs Gerber. Output directory. You're gonna dump all your things here. This is my project name. I'm gonna call this one Gerber. Okay, my op amp or universal op amp David, or no, I don't know. My PCB David S EE 320 Thursday Gerber. Okay, I'm just calling whatever, okay? Select. And then press no, okay? Press no, okay? This is the one I have to tell you. Press no. Okay? We don't want to do relativity. Just dump it there, okay? I don't want to deal with paths. Plot. Press the plot button. Let it do its thing. Then press generate drill files. It should call the same output folder. Just press generate. It says done. As in done with you. I'm playing no. Anyways, we're done with the the lab. Let's go look at it. Where's my Gerber file? Or where is it? Where's that funny long name? Where'd it go? Maybe I should have checked where it went. My first PCB. Let me check. It's there, right? Let me see. Oh, right here. I'm so dumb. Anyways, there it is. You see that there? Gerber. Compress to zip file. Let it do its thing. Go here, and you're going to show this in your post lab too. I'm in incognito. Whoopsies. She's my real thing. Osh Park. Okay? This is the final snip. How much is this going to cost? And this is what I'm going to do next Thursday. I'm going to bring my nice lab hat, coffee, and be like, spending the dean's money. Shh, don't tell him that. Well, I am spending his money. But anyways, I'm very happy that he's giving me this opportunity again, because this is going to be about $1,000. Woo! Looking cute, right? So you guys are going to go, I don't know, Hawaii or San Diego or some cool spring break trip, right? So what I want you guys to also do is make sure you have labels. Okay, you see how there's labels? Like this is the minus 9 volt, plus 9 volt, right? Right? What about this one? This side right here is the GND V plus of the op amp, right? What about this one? This is my input, and I can move this. What about this one? Give yourself some labels, okay? You're not going to remember this lab in literally 3 weeks from now. I'm gonna buy these boards next week. They're going to fabricate for a few weeks, okay? 2 weeks max. And then we're going to solder these boards, okay? Someone already put like an anime girl. Someone made a donuts. They made a donut PCB. And I was like, you're a little bit more expensive, but I was like, you fit it. It's cool. Oh, shoes. I wish I can show you my cactus. Hey, Leo, can you go to 311 and find some PCBs? There's a cactus PCB. There's other purple PCBs. Can you go bring them?
Yeah.
Thank you. So, yeah, someone made a donut PCB, which was like, I don't know. It was cool. They promoted their, like, what do you call it? Video game that they've developed as a QR code, and they put it there. So they're handing that as a card. I'm like, whatever. Okay. So I'm keeping it strict here. Try to keep it the same board. We're doing the simple voltage divider, right? And we're doing the universal op amp, right? Have fun, okay? Make sure you put your name, your partner's name, you guys have my Thursday lab, whatever I asked, okay? Lab 5 EE320, because these are boards I'm going to present to the dean, okay? Are there any questions? And then, yes, this right here is the final DRC. And I need to see this right here too. 1.45 times 2.23. 2.33, right? 3.37, right? Or 1.45 times 2.23, right? 3.23 times $5. Is that close to my 16.15? Right? They gave me a penny discount. And that's your final picture for your lab report. Are there any questions before I end the video? All right. Have a good day, everybody.